Hello, sixth graders. Today we're going to be working with the distributive property. We're going to be spending about 2 or 3 lessons with the distributive property, and it's pretty basic and easy. We're just going to be multiplying and adding and subtracting numbers, okay? Let's take a look here, and I want you to follow along with your study links. It says, for each expression in the top row, find one or more equivalent expressions below it. Fill in the oval next to each equivalent expression. So this is what we have right now. We have 8 plus 7 in parentheses times 4. We got to know which one of these down here equals the same thing as that. Well, we've done this before where we can go 4 times 8, 4 times 7. So it would be 4 times 8 and 4 times 7. Anything like that? This first one would be 4 times 8, 4 times 7. Okay. We also know that this equals 32 plus a 28. That's another way to kind of see this. Let's see if anything else here looks the same. We could probably also do something like this. It could be 4, and then like Pem does, times whatever is inside, which would be 15. Could also be the same way to write this. Well, let's take a look here. 4 times 7 plus 8, does that equal the same thing? It sure does. All we did was flip the 7 and 8 around. That one works for an answer. And let's see any of the other ones. Well, we have 8 plus 4 times 7. That doesn't work because you're putting the 4 into the parentheses. So that would be 12 times 7. That is not the same as 4 times 15. And then 8 plus 4 would be 12 times 7 plus 4, which is 11. 12 times 11, that does not equal the same. That's a much different number, a much higher number, because they're multiplying inside here. So the first two would also be equivalent, or would be equivalent expressions. Let's look at the next problem here. It says for each expression in the top row, find one of the equivalent expressions below it again. So we have 6 times 5 plus 6 times 8. Well, before I even look at any of these, I'm going to take a look at what this is asking, okay? First of all, another way to write this would be 6 times be the 5 plus 8. Because the distributive property is this right here, where you're just extending it out where it's going to be the 6 times 5 plus 6 times 8. Okay, so I'm multiplying into each one of these. That's all we're doing here, okay? Let's take a look here. What answers could possibly work? Well, this first one is 8 times 6 plus 5 times 6. Okay, does that work? Yeah, that's exactly what I have written down right here. So that's my first one. 6 times 5 plus 8. I have it written right here. It's more condensed. It's not in the distributive property. That one works. Now I have 8 plus 5 times 6. Does that work? All we're doing is we're rewriting this right here. So it'd be 5 plus 8 times 6. It's actually the exact same problem as that. So that one works as well. We're just kind of flipping the numbers just like the last problem. It doesn't matter if we have times 6 in the front or the back. That one works as well. How about down below here? This would be 11 times 6 plus 4 is 14. That does not work as the same as an equivalent equation to this problem right here. Let's take a look at this next problem here. So now we have 3 times 9 plus 4. So before I look at anything, another way to write 3 times 9 plus 4. Well, I can multiply 3 times 9, and I can add that to 3 times 4. And the only reason we're adding in between here is because we're adding inside those parentheses. So, does anything looks familiar to these on this problem here? 9 plus 4 times 3 plus 4. This is a trick problem, so this one doesn't work because you're adding inside and multiplying in the middle. We're adding in the middle here. We have 9 times 3 plus 4. Does that work? That does not work because we're multiplying by 3. How about 3 or 4 plus 9 in parentheses times 3? That works. It's the same thing as this, except for the 3 is on the outside. Then we have 9 times 3 plus 4 times 3, which is exactly that problem right there. So that is also equivalent. Moving on. The area of the rectangle M is 45 square units. So this entire rectangle is 45. Okay. What is the value of B? So we're trying to find out what B is right here. Well, I tell you this much. This 5 right here, 5 times 3 plus B, will get equal 45. Because we're going to have to add 3 plus this b to make this straight line, plus or times the 5, and this for 3 plus b has to be inside parentheses. Okay. So then I'm asking myself, what number times 5 could get me to 45? Well, 5 times 9 will get me to the 45. So 3 plus 6 will get me to 9. You can see how I kind of worked that out there. I had to problem solve here for b. I could also set this up like an equation. 5 times 3 is 15, plus 5 times b is 5b, equals 45. I can bring this 15 over to this side, then it becomes a negative 15. 45 minus a negative 15 is 30. I have 5b equals 30. Divide by 5, divide by 5, b also equals 6. So what does b equal? It equals 6. There's two ways to show it. That's why I changed the color of my marker. Write two different number sentences to describe the area of the unshaded part of rectangle M. Let's take a look here. So I have to find the area of this unshaded part. So there's a couple ways to do this, okay? One way I could do it is I could go 9, because I know that whole length is 9. 9 minus 3, that's going to tell me what b equals, times 5. 9 minus 3 would be 6 times 5, which is 30. Another way to write that down would be 9 times 5 minus 3 times 5. Because if I go 9 right here, times 5 would give me 45. Minus the 15, which is this shaded part, it would give me 30 for an answer. That's another way of solving this problem. Moving on here. Each of the following expressions just describes the area of one of the rectangles below. Write the letter of the rectangle next to the expression. Well, here we have 2 plus 3 times 7 is an area right here. This problem right here is going to be 2 plus 7 times 3. Right here we have 3 plus 7 times 2. So let's take a look at this first one. We have 3 plus 2 times 7. So 3 plus 2 times 7, this is shape N. 7 plus 2 times 3, that's right here. This is shape O. 2 times 7 plus 3. 2 times 7 plus 3, that is angle P. Now we have 2 times 3 plus 7 times 3. Looking at all the shapes, that right there would be angle O, because this would be 2 times 3 to get this shape. 7 times 3 would be this shape right here. So this is angle O. 3 times 7 plus 2 times 7 will be angle N. Let's take a look here. 3 times 7 would be this shape right here. And then we have 2 times 7. We have 2 times 7 would be this shape right here. So that is an N right there. The last one is 3 times 2 plus 7. 3 times 2 plus 7 would be an answer of, 3 times 2 plus 7 is O. Okay. Sandra wants to buy envelopes and stamps to send cards to 8 friends. Envelopes cost 10 cents and stamps cost 39 cents. How much will she spend? Well, if you're taking a close look at this, we need to try and figure out how much she would spend. So if she has 8, so she's going to have to go 8 times 10 cents. She has 8 friends and they need envelopes for 10. Plus 8 times 39. That'll tell you how much they equal. So I'm going to grab a calculator. 8 times 10 cents would be 80 cents. Plus 8 times 39 is $3.12. So if I add those two together, I'm going to get an answer of $3.92. So our number model to express this answer would be right in here. So you'd write that on this line right here. And the dollars is $3.92. Okay. Basically today the distributive property is you're distributing a number across parentheses and adding and subtracting. We're going to be spending some more time working on this tomorrow too. I have a really nice video that it's not going to be a recording of me, but it's going to be a nice video that's going to show you some more examples of distributive property. Hopefully this helps. Good luck, and I look forward to working with you in math.